All right, hi guys. Today we are going to look at how to solve radical equations. This should be a pretty quick video. I wanted to fit it in with the last one, but the last one ran kind of long and I didn't really want you guys to have like a 30-minute video. I thought that would be crazy, so I just made them two separate ones. One like kind of large and then one kind of small. But anyways, let's get to solving these radical equations. Okay, so first we're going to talk about like some technique. All right, so this should be, like I said, pretty quick. All right, so solving radical equations, I like to kind of think of this as like two steps. So step number one, which is very important, is you need to isolate whatever has the radical. That means get that radical by itself. All right, so that is always going to be your step number one. So we want to isolate the radical. All right, and like I said, that just means get it by itself. All right, so once you have your radical by itself, so you've moved everything else to the other side of the equation, what you want to do from here is you want to use inverse exponents. All right, so the second technique is to use inverse exponents. All right, so if you see that your radical is, say, the square root of something, well, the inverse exponent is squaring it. If you have something that's to the power of 1/3, well, the opposite or inverse of 1/3 would be to raise everything to the power of 3/1. So once we have isolated that radical, then we're gonna go ahead and we're gonna use those inverse exponents. All right, and that should make our radical go away in our problem. All right, so those are our two things that we're going to do. So the first step, isolate the radical. Once it's by itself, you can go to step two, which is to use inverse exponents. All right, after that, we're just going to solve it like any other normal kind of problem. All right, so let's go down here to this first one. All right, so we have k minus 18 to the power of 1/5. All right, I'm going to zoom in a little bit. There we go. Okay, so first thing we want to do, just like I said in our steps above, is to isolate the radical. So in this one, we have a fraction exponent, so we don't actually have the radical symbol, but hopefully you guys remember from the last video that if you have a fraction as your exponent, then that means you do have a radical in your problem. All right, it's just not written like that, but it's the same thing. So what we want to do is we want to get that parentheses that has the 1/5 exponent by itself. So to do that, we're going to have to add 9 to both sides. All right, that leaves me with k minus 18 to the power of 1/5 equals 2. Okay, now the next thing we want to do is go right to using our inverse exponents. This step is critical because what a lot of people like to do is they don't want to use inverse exponents because they don't like themselves, I guess. They want to make more work / wrong work. All right, what I see a lot of times is people trying to distribute that exponent into the parentheses. That is incorrect. That is bad math. All right, it is not even remotely close to what you're allowed to do. All right, so instead of trying to distribute it into the parentheses, which is wrong, and just doing things that are not right, and even if it was right, it's extra steps that are unnecessary. What we want to do now that we have it all by itself is we want to use those inverse exponents. So if I have something being raised to the 1/5, I want to do like the opposite of that. I want to raise it to the inverse of 1/5. Well, all I need to do is flip my exponent. So I'm going to raise both sides to the power of 5/1. All right, what that's going to do is it is going to kind of cancel out that 1/5. All right, so we are going to talk about exponent properties in our next video, but main thing is when you raise an exponent to another exponent, you're going to multiply them, and 1/5 times 5/1 is 5 over 5, which simplifies to 1. So they are basically just going to cancel each other out. So on the left-hand side, I would be left with just k minus 18. And on the right-hand side, all I have to do is take 2 and raise it to the power of 5 over 1, which is 32. Pretty nice. I have really pretty numbers here, and the rest of my problem is going to be a piece of cake. I just need to add 18 to both sides, and then I will be done. K equals 50. That's it. We are done with that problem. All right, so those of you who really felt the desire to distribute that exponent into the parentheses, that would not have made life easier and you would not have gotten the right answer. All right, so the two things, like I said, you need to remember. Number one, isolate the thing with the radical in it. And then number two, use the inverse exponent. All right, those are the two things that you have to do, and you can solve any radical equation. Okay, so that brings me to my second one, which is going to get a little bit tougher, but not extremely. It just has one thing in it that students tend to get wrong, which is why I wanted to show you guys this as our example problem. All right, so same deal though. I'm following the same rules. First thing I want to do is get the radical by itself. So in this problem, I do actually have a square root symbol. So I have the square root of 4k plus 20. I want to get it by itself. So the first thing I need to do is add 2 on both sides. Okay, that leaves me with a k plus 2 equals, and then I just have my radical for k plus 20. Okay, so at this point, I have now isolated my radical, so I'm going to move to step number 2 for solving, which is use inverse exponents. All right, so if I have this square root of something, that's the same as raising it to the power of 1/2, and the inverse of 1/2 is 2 over 1. So I am going to essentially square both sides of my equation. Now, this isn't complicated, but people do tend to get this wrong because what they want to do is distribute the exponent. And just like we talked about with the last problem, you cannot distribute exponents. That is not how exponents work. What exponents mean is it's telling you how many of that quantity you have. So for this problem, this is telling me that I have k plus 2 twice. All right, so it is more accurate to rewrite it like this. Okay, I did not distribute that 2 into the parentheses. Do not do that. People do it all the time, whether you're honors, regular, AP calculus students, it doesn't matter. People do this all the time, and it's infuriating for your math teachers because it is wrong. It is not right. It is wrong. All right, so that is my rant for the day. So when you have k plus 2 quantity squared, you're not individually squaring the pieces, you're squaring the entire side of the equation. All right, which means that you have k plus 2 twice multiplied together. So we are going to have to FOIL this. All right, so on the other side of the equation, the squaring and the square rooting cancel each other out. So what you're left with here is just 4k plus 20. All right, so that side is easy. All right, now what we have to do, like I said, is we're going to go ahead and we're going to FOIL first, outer, inner, last. Our, oh no, hold on, there we go. Okay, we're back in business. All right, so we are going to have to, draw plus 20. There we go. All right, sorry, technical difficulties. First, outer, inner, last, right? So k times k, k squared. K times 2, 2k. 2 times k, another 2k. 2 times 2, 4. All right, equals 4k plus 20. All right, now we're going to go ahead and we're going to combine like terms on that left-hand side. So I have a 2k plus a 2k, that's going to give me 4k. So I have k squared plus 4k plus 4 equals 4k plus 20. All right, from here, I'm just going to solve my problem. So I'm going to first go ahead and move everything to one side of the equal sign. Anytime I have something squared and then something not squared, like this one I have k squared and I have a k. My next step is generally going to be to try and move everything over to one side. So I'm going to go ahead and subtract 4k and 20. That's going to go away. So over here, I am left with k squared. Now 4k minus 4k is 0k, so that's just going to go away. And then I have 4 minus 20, which is negative 16, equals 0. Now you have two options for solving this. One thing that I will say is that some people do this by adding the 16 over to the other side, and there is nothing wrong with that. You can absolutely add 16 over to the other side, and I'm actually going to do that. But another thing that you can do is you can factor this. K squared minus 16 is the difference of squares, so you can rewrite k squared minus 16 as k plus 4 times k minus 4, and then set each one of your parentheses equal to 0 and solve. So we'll do like choose your own adventure here. I'll actually just show you guys both. All right, so factoring would look like this. So if I wanted to factor this, like I said, this is your difference of squares. So it's k minus 4 times k plus 4. And then you would equal 0. And then oops, roll that down a little bit. And then just like when we're solving a quadratic, we're going to take each piece equal to 0 and solve for k. So k minus 4 equals 0 and k plus 4 equals 0. So k equals 4 and negative 4. All right, so that technique is kind of the one I would recommend, just because when I show you the next one, we're going to talk about what the common mistake is for the next one. And so you guys will kind of see why I think maybe factoring makes you do less bad things, I guess, is what I'm trying to say. So the other way, though, that you can do this is by adding 16 to both sides. So we have k squared equals, so if I plus 16 here, plus 16 here, it gives me positive 16. All right, now to undo something squared, you have to take a square root. So we square root both sides, right? That's just using inverse exponents. And you